All right, so we're going to look at now we're going to look at um, how we name certain compounds, and this is called nomenclature. And there's a number of different types of nomenclature, and we're going to go through the first one here. So the first one, so actually, the system that we use for naming compounds is established by the International Union of Pure and Applied Chemistry, or IUPAC. Okay. And this is what we're going to be covering for the next three lessons for today. Okay. So the first one is binary compounds. Okay. Binary compounds are composed of only two different types of atoms. Okay. We looked at, ionic compounds and molecular compounds already. And so that's what binary is going to cover. Okay, so binary again is just two different types of atoms. It can be a cation or it can be an anion. It could be a cation or anion to form an ionic compound. It could be a nonmetal with a nonmetal to form a molecular compound. And there's different ways in naming these. Okay, so let's go through the first one. So compounds containing a monovalent metal with a nonmetal. Okay, what is a monovalent metal? Well, a monovalent metal indicates that the metal has only one possible charge. So up to now, we've only discussed or talked about monovalent metals, such as sodium, such as calcium, such as magnesium. Okay, and if we look at the periodic table that I provided you on the thing, on the classroom, all right, we can see that most of our monovalent metals, okay, are group one, group two, uh, group three, and group four. Okay, the other ones are called multivalent, and they're located in the middle here, the transition metals right here. Okay, so we've already discussed monovalent, but just to let you know that monovalent indicates that the metal has only one possible charge. Okay, in naming, the metal ion keeps its name, such as sodium, such as magnesium, such as calcium. The non-metal ion is given the ending IDE. Okay, and again, we've talked about that with the ionic compound lesson. Okay, so just to remember that the IDE is given to the non-metal, so IDE. For example, sodium chloride, NaCl sodium chloride. Magnesium fluoride, MgF2. Okay, magnesium fluoride. Lithium oxide. Okay, you notice that the IDE is always at the end of it's not lithium oxygen, it's lithium oxide. IDE is put at the end of the non-metal name. Okay, so the crossover rule is used to determine the formula, and we discussed the crossover rule again in the last ionic compound lesson. If you are given the name of a compound, okay, the formula is reduced to lowest terms where possible. This is because the formula does not represent the actual amount of atoms, and you remember that it represents the ratio of atoms in that specific compound, not um, the number of atoms. Okay, so it's just a ratio. Remember, sodium chloride, you have a 1-to-1 ratio of sodium to chloride. If you look at magnesium fluoride, you have a 1-to-2 ratio of magnesium to fluoride. Okay, so it represents that ratio, and that's really important to remember. So I want to provide the formula for each of the following. Okay, so we have calcium chloride. Calcium chloride. Okay, if we're going to use the crossover method, we're going to need to look at the charges. So I have my periodic table right here. Okay, and I am going to look for calcium. Okay, calcium is right here. It's in group 17, so that means it has chlorine is in group 17, not calcium. It has a charge of, an ionic charge of what? -1 right here. Okay, you can see that this has a charges right here. So that's -1. Okay, so I am going to go back to my Jamboard here and put in a -1. Calcium, if we look at our periodic table, calcium has a charge of +2. It's in group 2. Okay, so I'm going to then go back here and put a +2 through my crossover method. I'm left with calcium chloride. Okay, sodium phosphide. Okay, if I look at sodium phosphide, sodium we know, I'm not going to go back and forth here. Sodium we know has +1. Phosphorus has a -3. So if I do crossover, I am left with sodium 3 phosphide. Okay, and then magnesium oxide. Magnesium has +2. Oxygen has +2. Okay, and I'm left with magnesium 2 oxide. Okay, but these cancel out because we're putting into the lowest term, so it's 1 to 1. So it's magnesium oxide. Okay, and that's what you do with the crossover method. And again, that should be a um, fairly remembered. You guys should have remembered that from the ionic compound lesson there. Okay, so we just covered those three. So that remember, you have to understand the crossover method in order to understand these. So I've just provided you with all three of those right here. Okay, so if you want to do those and work those out, you could pause the video and try to do those yourself. Um, but that's not the ones we really want to focus on here today, okay? We've worked with those ones before, so let's work on the multivalent. So compounds containing multivalent metal with a nonmetal. So you still have that metal with a nonmetal, okay? But now you have multivalent metals, okay? And multivalent metals indicate that the metal has more than one possible charge. And multivalent metals are found, and that's why we haven't covered them too much. Oops. Multivalent metals are found within the periodic table of the transition metals. Okay, if you look here on this periodic table, you can see that iron has, 3, a 2, a 6. What else? Tin has a 4, a 2. Gold has a 3, 2, 1. Where's lead here? Lead is around here. Pb right here. Lead 4 and 2. Okay, so all these transition metals, they all have more than one charge, one possible charge. So how on earth do we write that out? How do we write, iron chloride with knowing what the exact charge on iron is? We know chloride has a charge of -1, okay, but how do we know what lead has? Well, there's a way of writing it. So many transition metals between groups 3 and 12 can form multiple cations, like I just showed you. Okay, so determining the charge on the metal ion by using reverse crossover method or test cross, and I'll go through an example here now. Okay, so this method, the reverse crossover method, is really just bringing the numbers back up. So we have copper 2 oxide. Well, in this case, we need to figure out what copper is, because we can see here that copper has, where's copper? Copper has two charges. It has a +1 charge and a +2 charge. Okay, so how do we figure out which copper we're talking about, which cation of copper we're talking about? Well, we're going to go back here. We're going to do a reverse crossover. So I'm going to bring this 2 back up to the top of oxygen, and then I'm going to bring the 1 back up to the top of copper. And using the reverse crossover method, I can determine that copper then has a charge of +1. I can go back to my periodic table, and yes, copper does have a cation charge of +1, but it also has a charge of +2. But based on that reverse crossover, this particular compound is using copper 1. Okay, lead oxide. Okay, so how do I know which lead I'm using? We know that lead has two different types of cations, or two different charges on it, because it's multivalent, because it's in transition metals. It has a 4 and a 2. Okay, using the reverse crossover, I can bring up this over here, and then I bring up the 1 over here. Okay, and actually this is probably put into our into lowest form. Okay, because we know that oxygen, if we look at oxygen here, oxygen in our periodic table has a charge of -1, or sorry, -2. Okay, and it takes two oxygen to fill up this. So this is not right. This would be +4. Okay, this would be a +4. And let's go back to our periodic table to determine if lead has a +4 charge. It does. Okay, lead does have a +4 charge. Okay, the reason why we know this is because if I bring this 2 back up here to lead and make it lead +2, okay, this would have a charge of 2. This would have a negative charge of 2, and that doesn't equate. So let's go back to here. I'm going to show you here. So if I have lead, sorry guys. So I have lead oxide. Okay, I do the reverse crossover. I'm left with lead, +2, oxygen. But we know oxygen has a charge of -2. Okay, and if I were to use lead 2 in this particular situation, okay, I would actually be left with lead oxide if I were to do the reverse crossover here. Okay, but that's not what I was given. I was given oxygen has 2. Okay, it has a subscript of 2. So that means my lead must have double the amount of oxygen. Okay, so it would be lead has a charge of +4, oxygen has a charge of -2, crossover, okay, and I'm left with Pb2, oxygen 4, but remember we put it into lowest terms, so it would be PbO2. Okay, so I hope that one makes sense to you guys. I'm going to pause the video here, and then we're going to talk about the different ways in which we name these. Okay, there we use Roman numerals, the other one we use Latin names. Okay, and these again to name the multivalent ions. I hope that makes sense, guys. Stay tuned for part 2 of the binary compound nomenclature, naming multivalent compounds. Take care.